I don't always tell jokes about chemical equations, but when I do, there's no reaction. Stay thirsty, my friends. That's right, today we're talking about writing chemical equations. Hit the theme!
Ain't nothing but a chem thing, baby. Two flipped out teachers going crazy. Lancaster is a district that pays me. Unbreakable, so please don't try to break this. But back to the lecture at hand.
Hello and welcome to another episode of SchuFu Chemin at ya. I'm your host Fu, and with me as always is Shu.
Shu know it.
So in the last episode we talked an awful lot about chemical equations, and in this episode we're still talking about chemical equations.
Yup. So let's get started. Writing chemical equations, a lesson from the Formulas and Equations unit. Writing word equations. All names of reactants and products will be given to you. This is just a combination of formula writing and balancing equations. When you see the name of an element alone, simply write the symbol for the element. Be careful, an element does not have a charge like an ion, so make sure you don't write a charge.
Elements don't have charges and are neutral! When you see the name of an element that is a diatomic molecule, H2O2, F2, Br2, I2, N2, or Cl, otherwise known as Hofbrinkel or Brinkel-Hof if you prefer, it is assumed that you will write it with a subscript of 2. Note, this is not true when the element is found in a compound. When you see the name of a compound, look up the charges in your reference tables. Figure out the subscripts based on the charges like you did in the formula writing section of this unit.
When you see the name of an acid, go to table K and write down the formula given. No changes need to be made in terms of charges or diatomics.
So how do you know when you have an acid? It has the word acid in it. So all you have to do is go to table K. Don't overanalyze this. Go to table K, look up the name that you see, and just write down the formula.
When all formulas are written, you have the unbalanced equation. All you have left to do is balance it. All right, let's do an example of a word equation. You ready, Fu?
I am.
All right, good. The example says sodium plus aluminum sulfate yields sodium sulfate plus aluminum. All right, we just have to break this down into pieces. So Fu, let's start with sodium.
Okay.
Is sodium an element or a compound?
Sodium's an element.
Element. Okay, great. So what are we going to write down for sodium?
Just Na.
All right, do we need a charge for sodium?
Nope, just an element.
Good. And we're kind of in the habit of going right to our periodic table and looking up charges, but again, it's not in a compound, so it's just sodium. We write Na and we're good. All right, we've got plus, so let's write a plus sign.
That's easy.
Aluminum sulfate, element or compound?
That's a compound.
That's a compound. So what are we gonna have to do to write the formula for a compound?
All right, so since this is an anionic compound, I got charges. Let's look up charges.
Good, let's start with aluminum.
All right, I'm gonna do the work up here. So aluminum is Al, it's got a +3 charge.
Good, sulfate.
Sulfate's a polyatomic ion on table E.
Good.
That's SO4 with a -2 charge. So balancing them 6, it looks like I'm gonna have Al2, SO4 in parentheses 3. So write that neat down here.
Good, right, and we'll eliminate those charges. We'll be neutral now. All right, we've got our reactants because the next thing says yield. What do we write down for that?
That's an arrow.
It's an arrow. The reaction is occurring. Next, we have sodium sulfate. Element or compound?
That's a compound.
All right, so let's do the same thing we just did, looking up
Okay.
charges for sodium and sulfate.
So Na now is not just an element like it was before. Now it's in a compound. So
Good.
it has a charge of +1. And sulfate, oh, I already looked up sulfate. So
Good.
that's convenient. So SO4 has that -2 charge. So it looks like Na2 SO4.
All right, very good. So let's get that down. And then finally, we've got plus and aluminum.
Plus and aluminum. That was simple too.
Good. Again, no charge because it's an element. It's all by itself. We can't forget the very last step, and that is to balance this chemical equation.
Okay. All right. So I got 1 Na on the left. I've got 2 on the right. So I'm going to put a 2 there.
Good.
Next element I see is aluminum. I've got 2 on the left. So I'm going to put a 2 there.
Good.
And all right, sulfate, polyatomic ion. I've got 3 sulfates. I've got 1 sulfate. So I need a 3 here.
Good. Now, unfortunately, we just
Okay.
changed the NAs, which is okay. Trial and error is fine in balancing, but how many NAs do we have now?
All right, so I've got 2 on the left and I've got 6 on the right.
Yeah, so when you distribute, you get 6. So let's change that coefficient on the left there.
All right, so I'm gonna change that. If I can. there we go. Erase the 2, so that's got to be a 6, right?
Good. And as is always a good idea, let's just check everything real quick. How many NAs do I have on the left and right?
All right, I've got 6, and 3 times 2 is 6, so 6 on both sides.
Good. How about aluminum?
I've got 2 and 2. We're good there.
And just SO4 is 1 unit.
All right, so I got 3 and 3.
All right, we are all balanced. Nice job. You try number 1. Magnesium plus hydrochloric acid yield magnesium chloride and hydrogen. Please write a balanced chemical equation, making sure to use table K to get the formula for your acid.
Predicting products to single replacement reactions. You will see one element and one compound. Look on table J and find the single element listed. It will be in either the metal or non-metal column. Find the metal or nonmetal in the same column that is already in the compound. If the single element is more active than the element in the compound, it will replace it. All right, ladies and gentlemen, we're gonna do some examples here. We're gonna take a look at some single replacement reactions, and we're just gonna see if they actually react or not. Shu, are you ready?
I'm ready.
All right, our first example here, we have FeCl3 plus Mg. So we're gonna find the element that's by itself, the single element.
All right, so that would be Mg's by itself.
Good, we're gonna find that element on table J.
All right, so Mg is in the metals column.
All right, now I want you to go back to the equation. I want you to find the element in the compound that is in the same column on table J.
Between Fe and Cl, I see Fe is also in the metal column with Mg.
Okay, now we have to determine if this reaction occurs or not. We have to see if the single element is more active or higher up on table J than the one it's trying to replace.
All right, so Mg is the single element and is definitely higher up than Fe. So I guess that means that it will replace it, right?
That is correct.
So then I say that yes, a single replacement reaction does occur.
Perfect. All right, our second example here, Al plus HCl. So let's find the single element Al on table J.
All right, Al is right here.
Okay, now I want you to find the element in the compound HCl that is in the same column as Al.
I guess it would be, I mean, the only thing I see like it is it's written as H2.
Yeah, and we've learned something about H2 already this year that might be a little out of the ordinary here.
Well, hydrogen is actually a nonmetal, but it's in the metals column.
Good, and that's a good thing to notice here on table J. Would you mind taking a look at the very bottom of this table? There's an asterisk down there.
It actually says that H2 is not a metal.
Okay, so yeah, H2, it's not a metal, but in chemical reactions like single replacement reactions, it likes to act like a metal.
Okay. It looks like Al is the single element and it's higher up than the H2. So that should mean that yes, a single replacement reaction does occur.
Perfect. All right, our third example here, we have Na plus BaSO4. I'm gonna kind of let you take the reins on this one.
All right, good. So I've got Na as my single element and Na is right here. And in the same column with Na is Ba. So we found the two metals. It looks though like Na is actually lower, so less active than Ba.
That's right.
So if it's less active, that means it can't replace it. So
good. So this reaction?
No, there's no single replacement reaction that will occur.
Good. All right, number 4, we have K plus HOH.
Well, I noticed that HOH is water, but it's been rewritten, so it must be because we're looking at K, which is metal column. And again, just like example 2, we're looking at hydrogen, H2. But it must be separate from the OH again, so that must be why it's written like that. So K is more active than H2, so there will be a reaction for single replacement.
Perfect. All right, our final example here, we have LAI plus Br2.
All right, well, the single element is actually diatomic,
Yep.
still an element. And Br2, that's actually a nonmetal. Br2 is actually in the nonmetal column this time.
Okay.
So if I'm looking for something else that's in the same column, it can't be Li, it's gotta be the I, but it's written as I2 on the chart, but
Yeah.
same thing, right?
It's an element, so on the chart, they write them in their elemental forms as diatomics, F2Cl2, Br2, and I2. Obviously, with Lii, it's in a compound, so it's not
It's
diatomic.
in a compound. All right, so it looks like Br2 is higher up than I2, so that means Br2 would replace in the compound. So yes, there would be a single replacement reaction occurring.
Perfect.
If a reaction occurs, look up the charges for the metal and nonmetal in the new compound. Do not write the subscripts from the original compound unless they are subscripts normally found in a polyatomic ion.
Don't bring over subscripts unless it's part of a polyatomic ion!
Write the formula of the compound. The replaced metal or nonmetal is written as a neutral element, and some of those elements may be diatomic. Finally, balance the equation. Examples Part 2. We're going to use Table J to determine if a reaction occurs, then predict the products. Finally, we will balance the chemical equation. You ready for all that, folks?
I am.
All right, first one, FeCl3 plus Mg. Let's start with a single element Mg.
Okay.
We're gonna look on Table J and find out what column it's in.
It's in the metals column.
All right, we're looking for another metal in our compound then.
It looks like Fe.
All right, so is Mg more active than Fe?
Mg is higher up on table J, so Mg is more active than Fe.
Good, that means a reaction will occur. Now, I want everyone to be clear that that doesn't mean Mg bonds with Fe, it means Mg actually replaces it. So I want you to draw an arrow from Mg to Fe, and sort of an arrow going out with the Fe. Kicking it out, that means Mg is gonna bond with Cl.
Okay.
Let's do our yield arrow, and maybe we'll show some formula writing work above, but we need to get a new compound between Mg and Cl.
So Mg will now be with Cl.
Right.
So is it Mg with Cl3?
We have to avoid the common mistake of carrying over the old subscripts. We want to make a brand new chemical formula between Mg ion and Cl ion like it had nothing to do with the original question. So let's look up our charges for Mg and Cl. We're dropping that subscript of a 3.
All right, well, since I'm looking up charges, I'm going to do this work off to the side here to not make a mess. So Mg and Cl. Mg has a +2 charge, it's in group 2, and Cl is a halogen, it's got a -1 charge. So balancing these, it looks like it's MgCl2.
Good, now clearly our Cl's are not balanced. Don't let that bother you. We will balance with coefficients later, okay?
Okay.
Now, the last part's kind of the easy part in terms of predicting products, because all we have to do is write the element that was replaced as an element, just by itself.
It's Fe.
Good, and we don't need a charge because it's an element. All right,
Okay.
very last step to finalize this question, we just have to balance, and that'll take care of the Cl that we talked about earlier. So go ahead.
Okay, so I've got 1 Fe and 1 Fe. Those are good, but my Cls I can see are not. I got 3 and I got 2. So I'm going to put a 2 on the left side, and I'm going to put a 3 on the right side. That gives me 2 Fes, which I had down so far. I'm going to put a 2 in front of this Fe now. So Fes and Cls are good. Looks like Mg has 3 on the right, only 1 on the left, so a 3 right there.
All right, looks very good. Let's do our second example. We have Al plus HCl. We can move a little bit faster here, so why don't you tell me what we should do first?
All right, so we look at our single element. I've got Al, that's a metal. I'm gonna go to table J because I notice it's an element, Al, and a compound, HCl, single replacement. Al, I see in the metals column, and then I see H2. Again, that's in the metals, even though it's not a metal. Al is higher than H, so this reaction will occur. So I'm gonna have Al bumping out H,
Exactly.
and H going away.
All right.
All right, so my yield, let's see. So Al will be with Cl. Again, I gotta look up charges. Don't forget
Exactly.
charges. So let me go up here. Al will be with Cl. Al on the periodic table is a +3, and Cl I know is a -1. So AlCl3. So that's my new compound.
Good. And now we've got to write our single element.
Plus H.
Be careful though, even though it's not written this way on the left, it's because it's in a compound, by the way. We have to remember that it's a diatomic. So when we see hydrogen as an element, we have to automatically know to write it as H2.
So whenever these elements are by themselves, not in compounds, they're diatomic.
Yep,
Gotcha. H2.
good. Now we can balance and finish things up.
All right, so 1Al, 1Al, good there. 1H, 2H. Let me put it 2 there. CLs, now I'm at 2 and 3. So I gotta get those together. So it looks like I'm gonna put it 2 here, and then I gotta grab my eraser. Get rid of that 2. Because that needs to be a 6.
A 6, good.
And, oh, looks like my aluminum's now, right? I got 1 and 2, so I'm gonna put a 2 there. So I've got 2 aluminums on both sides. I have 6 hydrogens on the left, so I'm glad I double checked.
Yep, always good to double check
All
at
right,
the end.
so there's a 3 there then. All right, so let's double check again. 2 ALs, 6 H's on each side, and 6 CLs on each side, so we're balanced.
All right, good job. You try number 2. For each of the following reactants, you're going to use Table J, see if a reaction occurs. You're going to predict the products, make sure you're aware of formula writing for compounds versus elements, and finally at the end, you're going to balance the whole equation.
Well, that's going to do it for today's episode on writing equations.
It's been emotional.
Today's episode was brought to you by
A1A Car Wash. You've tried the rest, now try the best.
But we never off, always on till the break of dawn. SCIENCE in the hall they call S-Wing. You know we never wear a tie, like my homies, boys to men, it's so hard to say goodbye.
Like this, that, and this, and it's like that, and like this, and like that, and it's like this.
You're going in low power mode.
Plug and chill to the next episode.